Yes. So then we're going to talk about the job scheduler. The job scheduler is a very central piece to a supercomputer HPC system. Um, because with the job scheduler, this resource gets shared among the users. Um, so without a job scheduler, we could easily have a situation where it was first come, first serve, and then a kind of monopolizing use of the resources. Um, uh, but with the job scheduler, we request for access to resources, and and the job scheduler then fit our request into a scheduling plan. We have compared the work with the job scheduler with a restaurant, um, and 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 it's a very good comparison, really. If you you're on your kitchen, you can serve dinner to you and your partner immediately or at any point in time, or you can go and grab something to eat. And that's like how your laptop works. But maybe you can't invite all your friends to your kitchen. If you want to meet all your friends, you have to go to a restaurant, and then you have to reserve a place. And the restaurants I say, "Yeah, you can be here at 6." And if it's a very popular restaurant, then you will get the message that you need to leave at 8. So with the job scheduler, it's approximately the same. Um, but you don't, but it's the job scheduler that decides when your job starts. So you say that, oh, I'm going to run for 24 hours. And then the job scheduler find those 24 hours for you. The job scheduler will then also kill your job if after 24 hours. So if your job needs more time, uh, uh, you really don't have any means to change. So setting the right time for the job is quite important, and this you will learn as you go. It comes with experience, really. Uh, it, it feels quite challenging at the start to set the time that you need, uh, but it doesn't cost you to set too much. You don't lose that time. You will only be accounted for the time that you use. Um, and with time you will get the feeling how long a job takes. Yes. So uh, and a restaurant or a kind of shared resource. You come there and there are a lot of other people, and you fight for the attention of the waiter and getting your food in the right time. And this is like also on the HPC system. Yeah. HPC system is a shared resource.
But I see there's a table that it says reserved there. Is that similar to what we can have on an HPC system also? Could some nodes be reserved?
Yes, some nodes could be drained and taken down for system maintenance. But you also can have nodes that are reserved for for incoming type of jobs. Um, I'm not sure we have a reservation now or currently in this course, but we had that previously. And then we have higher priority and go go ahead, come first in the queue. 10 years ago, our systems used to run the weather forecasts, and then the weather forecast would come in at a regular time, 12, 6, something like that, and several times a day, and then so these resources were available in between, but then were used at regular specific time points.
Yeah. And I also want to mention that, there's a table there with one free chair. And then there's a full table that's free. So this queue manager, if there's one person in the queue here that kind of says, I'm going to eat alone, he could be placed on that one empty chair.
That's right.
That's similar of course, the whole point is to show similarities with the scheduling system. So if there are some cores that are not being used on the node and somebody comes with a small job, it will be put there and to try to maximize usage.
But this person also can say that I want to eat exclusively. I want to eat alone.
Yeah.
But then you pay for the. It could be then you said that you have to pay for the seats of the rest of the table.
Yeah.
So then if you're alone, you are exclusively on a node. You will pay for all the resources on that node, all the CPUs. That's right. So creating our first Slurm job. Yeah, we talk about workloads. That's the jobs that's running on the HPC system, and they can be interactively, or they can, as the most common jobs are non-interactive jobs. And another name for scheduling system is batch system. And this is so we submit a job to a batch system, and this software service then run all jobs in batches. So let's see here. I'll use Nano to create an example. Yeah, and I hope you see my terminal. I also have a history window below here, so you can see the examples, the commands that I write. And I'll just paste this text, the commands into the normal terminal.
So Björn, should people follow along now, or
I think we will have an exercise afterwards
right.
where you will write your own batch script. So we will, people can just watch. So now I have written an bash script example. Job.sh. So if I try to run this now, it doesn't run. The my tab expansion doesn't work. Press tab now because there's no execution mode on the file. You can see that here. Example. It's only read write. And if I try to still insist on trying to run it, I'll get permission denied. So this, so I have to add the execution bit to this file, and then if I press tab expansion now, it will expand into example -job.sh. So then I can run it. Now I'm running on login 4. So still like this is not a batch job yet. So it's just a script that I'm running on the login node.
So please ask questions in the collaborative document if you were wondering what happened now, and we will try to elaborate.
We will run it on a compute node. So to run it on but as I said when I talked about the restaurant example, there is accounting ongoing when you run on there's no accounting on the login node, but there's accounting on the compute node. So if you don't have any compute time, you're not allowed on the compute node. So and the way you find your compute time is with the command projects. It shows which projects I'm a member of, and when you all should be part of the NN9970K. And this is probably not shown here, but I can show. There's the command cost, which shows what you have on your account. I think it's cost minus P to show the project. Yeah, so we have 55,000 hours, CPU hours, and most of it is available. So this can be useful to check if you're not sure if you have enough compute time. Yes, so we submit a job with the command sbatch, and we see that we need to add the project name to the account parameter. I don't like to write very long lines, so I'll add a backslash so I can continue on the next line. And then on Saga, we have to specify the memory. I don't think you have to specify that memory on Thrum. And this can be a little bit annoying when you move from system to system, what you need to specify or not when there's differences. So we specify that we need 1 gig of memory, and the time we're going to use. So here we says this is 1 minute. If I wrote 7 or 6, if I wrote 6-000, that would be 6 days. There's the days first, then hyphen, then hours, then minutes, and then seconds. It will not run for 6 days. It will just run for a minute. and then it's the job itself. So then it's just return, and I get that number back. I could.
So now, actually, what you did now was actually send that script, which is now possible to execute. You sent that to a compute node, or you didn't, but Slurm did, and then it got submitted, and it will run on a compute node, right?
Yeah. So now I've contacted the restaurant and asked for a table. That's what I've done, and then the queue manager received this and make a reservation for me and run the job. Mm-hmm.
Can I just say your terminal is slightly cut to on the left side. If you could drag it a little bit to the right, we'll see the hole. It doesn't really.
I understand. I see what you mean.
Just slightly.
There.
Yeah.
Yeah. So there's a command SQ, and if I then write my name, my username, I'm not just my username, but grep, like something like this. If my jobs is queued or running, I should be able to see it. But if it's already executed. So, but if you have long running jobs, then you will get the queue information or the running information for the job.
Maybe you can show SQ how it looks anyway with even.
Yeah, it shows all the jobs that's currently running. So in this, so this, so here we see I use Olavga have several running jobs on several nodes, and R are running jobs, and if there's some Q is queued, pending. It's not queued, but it's pending. So Olavgal has a lot of pending jobs as well. Yes. And here we see whether it's running. These running jobs are in the big mem partition on this compute node. So that's I'm using grep because normally I'm not interested in all this. I'm not interested in what other people are doing, so I will only be focusing on my jobs.
Yeah, and I think Ole or somebody wrote a message in the collaborative document that you can use SQ-me also for a short,
Yeah, okay.
or a simple way of seeing just your jobs.
But then now the batch shell or the queue system has created output files in my directory in my working directory where I submitted the job from. So we have the slurm and with the job ID dot out. So there we should see on which compute node we were running. So if I just cat that job file, yeah, we see a lot of different things. Let's see. We see the start of the job. Here's the output. This is running on C5-59. And then we get the information about how much resources we have used, what how much we are billed for this job. It waited 11 seconds in the queue. We requested 60 seconds, but it only used 3 seconds. But it exited normally, and some CPU statistics. Yes, so you also can use SQ minus $user then, so to get just your information about just your job. Is there any questions in the shared document?
Not really.
No. Yeah, and here is also a good one. If with this iterate, it will run this command every 50 seconds. So then you can have a terminal window with SQ minus your username and iterate for every minute or 10 minutes, or if you have a very long running job. Yeah, so we saw where the output was, Slurm and the job ID, and then and the contents. Yes, if there was an error, this will also be in the Slurm output file. Um, so here, there's probably an error. Here, the hello.sh is not there, so you get the what's written to standard error as into the output file.
Yeah, and there you see job failed in the.
Yeah, and there you have job failed, not exited normally as the other job.
So should we do this exercise? That's
Yes.
just a bit above there.
Yes. Which are you thinking about?
This the one update job, example job.
Yeah. Yeah, we can do that. 10 minutes. Looks like if you have been able to run jobs. So we'll continue with the lesson. Just was a question here on the bottom. Okay. Seems like it's taken care of. So what I did was that I want to run the job with the batch system, that I specified everything on the command line, like I did here. So remembering all this with it And also remembering what the correct string is for the different systems is can be a little bit tiresome. So we need to write all these parameters to the sbatch command into a file, so we have it somewhere. And that's what we're gonna do next. So we see here an example job script which does the same, running host name, and it sleeps is in for a minute, 60 seconds. But what's new here is this sbatch entry where we add a job name, a new name, and add a job name to the job. And in this way, we will be able to very easily see the job, this job in the SQ output. So if I do this, I'll modify my example job. So now no, and you can just watch me do this. Job dot shell, and I'll add the sbatch job name, my test job, and we can add, oops. I'm not used to using nano, that's so when I edit things, I do VI commands, and then things turn out differently.
Björn,
Echo.
I see.
Yes.
I'm confused with this $S badge. What is that here? Isn't that a comment? Maybe people are used to seeing the
hash
used for comments.
Yeah, the scheduler parses the whole script. It doesn't. If you run this in a bash shell, it will be taken as a comment. But the scheduler does take this as a parameter entry when it.
Right. So there's the Slurm software will actually discover that there's a hash
Yes.
sbatch, and it'll read this and take that as Slurm commands.
Yeah. And we will see that we can add a lot of those, like adding the account and the time and the memory, and a lot of different parameters can be added in this way. So there we have it. So if I'll now search for my sbatch command, and I'll run. This should run, and then we'll should see my test job listed in the SQ in output, and especially since it's 60 minutes sleep, so we'll stay in running mode for more than 60 seconds. So SQ me, here is the output. it has a name, my test job, and it's the pending status. Yes, let's see here. Now it's your turn, I think.
Yes, because I was
No, not your turn, but
exactly. Okay.
but the user.
The participant's turn to do an exercise.
Yes, that's right. Sorry for being imprecise. There are different. So here's an exercise, and you can then add mem time and account, and you can also change the name of the output files and also get directed errors to an output file, and no output to an output file and errors to an error file. So you can start doing this exercise. Probably you need 15 minutes for this one.